All right, thanks. So that last one got a little heated, which is awesome. But maybe we can talk about something that'll help some of the problems that were being talked about before. So this is fucking IPC because it was fun to say. Um, or is it IPCing fuck? We're gonna make fuck faster. That's the idea. So we're gonna start by kind of laying out the problems that FSC has and what IPC has today and how we could possibly work together to make something better and faster.
I'm here to give the requirement from the Filecoin Onchain cloud side. It's the bottleneck that we're seeing building with the builders and ourselves. Like these are the bottlenecks we we think is bad, and I don't know why since it's cutting off. The first thing is just like there's oh fancy. Okay. So there's like a everyone knows there's a 30-second block time on Filecoin L1. Even with like we have like fast finality on L1 right now, it's finalizing under 2-3 minutes on average, I think, give or take, up to 10 minutes, let's say that. But still, even if it's finalizing in one block time immediately, it's gonna take like a 30 second. So a couple problem with that when we're building a data storage service. First is like what we learned is like builder when they are buying services, they just want like micro payments like X4 tools. So with Filecoin Pay right now, it's more like a prepaid like debit card. You put the deposit down and you can use all the services. The first initial setup does take up to 30 seconds based on how fast the transaction got confirmed. The payment itself does process automatically, so kind of like a microservice, but then the full execution of the payment is executed upon the settlement. And we can only recommend anyone can settle any payment rail, but like we only recommend people to settle their payment rail periodically to avoid very high gas costs coming from like each settlement. So that's kind of have micro payment, but you don't really have micro payment because micro payment is like, hey, every time you get paid, the money is in your bank account. Right now, it's like virtual money in your bank account, but not actually in your crypto wallet just yet. So that's one requirement. It's like we want to be able to support faster micropayment. The other thing is like builders do want faster service confirmation for low latency. So we are trying to build like data gravity with the data storage services on Filecoin. However, a lot of the services like Filecoin Beam, for example, they are relying on the signal that, hey, this CID is landed on chain for the storage services. Now I can apply this additional services on top of that. Waiting for that on-chain confirmation right now does take at least one block time, which is 30 seconds, which is not fast enough for a lot of the use cases. I do want to mention it's different from when data is available because like data is available from the storage provider as soon as the data is uploaded. So it's separate of concerns, but like when you are packing the services, especially building on-chain things, you do want to wait for that on-chain confirmation. And we do want to simplify that DX and to bring bring lower latency to the builders. So that's another requirement. And also builders want like more smart contract capability, while Filecoin FVM does support EVM. However, there's a lot of capabilities or the new EIPs or the features builder are leveraging is not in the FVM right now, including like gas-based transactions, account abstractions, like compute and so on and so forth. Some of those capabilities that builders want to build data applications or like product around data storage services, they cannot just do everything on Filecoin at the moment, and we do need like flips to upgrade and the network upgrade to support some of that, which is a very long process, which is like 4 to 6 months. We can say maybe this is less of a problem if we figure out how we can export Filecoin data storage services to other chains, because then let the programmability capability to be handled on other chains, and all we offer is like data storage services. Maybe that's okay. However, that is one thing that the builders we're hearing is has a requirement. It's like I want this additional functionality that I can do in the smart contract, and I cannot easily do that on FVM. And that's another thing we are hoping to have a solution for. In general, is that what we learned is even Web3 developers, they just want to build products that offers Web2 UX, but paid in stable coins or so on and so forth. So that's very important, and that's the goal we want to work towards.
Awesome. So if you don't know what IPC is, it's basically modular configurable blockchains that roll up to an L1. They are hierarchical, but that doesn't really apply in this case. We have reached sub-second block times, which could be a big impacting factor for FOC. Really inexpensive transactions. We have WASM actors, which can extend functionality beyond what Filecoin has right now. It works with F3. We're working on adding storage. I don't know if that would be useful in helping FOC be faster or not. It could act as a cache layer for the data while it waits to get uploaded. The basin is the package that we've integrated with IPC, and it actually has an S3 API with it. So there's potential there to have something added on pretty quickly. And we need use cases. So we're looking for ways to use IPC and get it out into the real world. So why it matters, I think Jenny covered it pretty well. If a developer is trying to create a DApp, and imagine if you're trying to upload your profile photo, waiting for 30 seconds for that to upload, it's such a small file, it doesn't make a whole lot of sense. Attachments or real-time apps, it just doesn't quite work. We want to unlock Web 2 level experiences, but on Web 3, so you get the best of both worlds. Current state is, I think you all know, the user uploads a file. We got to wait 30 seconds for the block times until it's done. Ideally, we'd have something where the user shouldn't know that they are interacting with a subchain. They should just feel like it's the same process. They upload the file to IPC. It gets pushed. We've got to figure out how to handle the burn of fill if we're interacting with the IPC subnet. Those tokens still have to be burned, so we've got to figure out how to do that. And we have to figure out if the files are cached or just pushed directly to the L1. So these are the three big problems that we're aware of. Are there any that we missed? Anybody aware of any other problems? I think Jenny covered it pretty well, but anything else? No? So I think what we would like to do is break out into 3 groups and have kind of jam session on trying to figure out how to solve some of these problems. The first one is fill burning on L1. So if we were to push a transaction to an IPC subnet, how would we get those tokens from the subnet into the L1 to burn to satisfy that requirement? Second one is the file flow. So do the files stay in IPC? Are they cached there? Do they get pushed to the L1? How all that works. And then the last is the developer and user experience. So what it's like to use it and how can we make it so that it is something that everyone would want to use. It's not more complicated than the existing solution. So I guess we'll have group 1 over here at this table. Group 2 can be right there in the middle. Yes. Not quite. It's between 500 and 900. It usually averages out to about 800 to 900 currently.
First topic to discuss, how can we use IPC to do X402 verification in real time?
I'm not sure. That may be a separate discussion.
So you think it doesn't apply to this?
I'm not super familiar with 402.
So basically what I need to do when I'm handling a retrieval request, I want to settle the payment in real time in that under 1 second block time so that the content provider knows they are getting paid and so that they can return the requested resource. Right? Oh, true.
Yeah.
Okay. Yeah, sounds good.
Yeah, I could jump, but we could find out. So yeah, then the third group, probably at this table, that's the developer and user experience. And so we have, if one person from each group would come to me, I can share the slides with you, and you can just directly fill in what you come up with in the slides. So we have a little.
I think for each group, we need one POC that's like driving the conversation. So who wants to store the conversation of group 1? Fill burning on L1?
Yeah, who understands that the best?
Oh, I want Kuba in group 2.
I'm really sorry, but I've got no idea how IPC works, and I wonder, Because it seems like you need to know that to answer any of these questions. And I'm wondering, do we have people in the room that have a clue that could help us answer? Because
It's
I can't answer.
we could, yeah.
Because from a design perspective, you know, from the product experience of benefiting and solving these Filecoin on-chain cloud problems using Filecoin on-chain cloud running in an IPC subnet,
Right.
where you have effectively the warm storage service that is operating in an IPC subnet, which is operating like a normal blockchain network, right? And so it's running as an EVM smart contract there. Then you are going to need to do a message to the parent, which is a burn message or a send to the 009 actor on Filecoin L1 when you want to like burn fill associated with a market fee. And so, you'll need to use the IPC general message passing in order to send to that actor. Right now, there's an auction contract that is actually even converting between user submitted USDFC into into fill, so that you can then burn that fill as part of the network market fee that's happening there. So I think that's a you question. You need to figure out how we can do a IPC L2 to an IPC L1 or to a Filecoin L1 send to the burn actor from a EVM smart contract, and that should work normally, effectively with normal fill. Question 2: no, the files must live on storage providers registered with the Filecoin warm storage service. They're not going into Basin because that's a different project, and Filecoin on-chain cloud does not know what Basin is and shouldn't know what Basin is. And so they aren't being cached with like the IPC nodes because it's just the Filecoin on-chain cloud running in an IPC subnet. It should go to storage providers that have registered with the contract. Maybe there is some way whereby you can like effectively mirror probably from L1 to the IPC subnet list, like the warm storage service registration list.
Yeah,
Here are the storage providers, and those storage providers can keep submitting. Okay, but actually the storage providers are going to need to put their messages onto the L2 because that is where we then trigger all of the payments and other activities. And so all of the storage provider would need to be configured with that L2 chain ID of like, here's where I send my messages, and then they're going to get bubbled up into L1 and probably, power dashboards and other things like that. So in that world, are they L1 storage providers? Are they L2 storage providers? They're just Filecoin on-chain cloud storage providers at that point. They're just Filecoin storage providers, and they're gonna talk with whatever smart contract on whatever network you tell them to submit their proofs to. And I think a lot of 3 is very interesting, and I don't know the answer to that, and the question is partially that's going to be an interesting design discussion. But at least I feel like one is relatively solved as long as you allow good message passing.
Yeah.
2, they need to go to storage providers, but those storage providers are going to need to be pushing their proofs to the L2 FWSS contract in order to get the fast block times. And then that hits 3. How do developers, users, and storage providers interface effectively with a warm storage contract that's running on a different network? And I think that means that Curio and other things will need to configure that network and the smart contract address. Instead of operating with Filecoin L1, they're going to need to be hitting this L2, and their Curio nodes and Lotus nodes will need to be able to interface with that network, get network state, push messages, etc. Follow block.
Ideally, it'd be a drop-in replacement so that you don't have to do extra setup or work.
We will also need RPC API provider to allow us to access and communicate with L2 with IPC.
Yes.
And also support in indexers, subgraph indexers like GoldSky.
I believe so. So we do have RPC. We have the ETH endpoints, basically.
But who's providing the RPC to those networks? Anyone right now, or probably not?
Good question. Probably not.
When we go to Protofire,
Yeah, hypothetically, it would be Protofire. I know they've done that in the past. So like Protofire, aka Glyph nodes, would provide an ETHRPC endpoint to all of those things. Gold Sky could probably integrate with that ETHRPC in order to give you the information. I don't know about Curio. Magic?
so maybe to paint some light on this, when I was implementing the thing which was called Udico, which turned into IPC after a long time. The idea was that it's basically a version of Lotus, which you have an additional RPC on that node, which basically says join this subnet, and then the Lotus node basically exposes another RPC endpoint for that L2. And this was a pretty good experience. I don't know why this was abandoned really. Maybe it's worth kind of looking at it again. But yeah, basically, I think it's feasible to add direct support for some kind of subset of IPC into Lotus. Maybe for those sort of chains where you have a direct API in Lotus where you just say, hey, I want to subscribe to this subnet or a few subnets. And then it's much easier also for Kuria to consume this.
I think it's a fantastic idea. Actually, it would make things move a lot faster. So it's 4:58. We're not going to get through all of these if we do them independently. Okay, so that'll work.
Yeah, how do developers, users, and storage providers interact with a warm storage with all of the different Filecoin on-chain cloud contracts operating on an IPC subnet?
Yeah, and I think that, again, my intent is to have it where users don't have to know that they're interacting with an IPC subnet. It should work as similar to it does now with FOC.
Yeah, but the flag there is like right now to interface with an IPC subnet, there is this like it's running a different consensus algorithm. There's a different node type to join that network. So it's not, you can't join an IPC subnet with Lotus today. So that's a hurdle. You couldn't have, it would not be out of the box for a storage provider or anyone else who's running a node in Filecoin, a client node, a Lotus, a Curio node, would not be able to join this IPC subnet right now, despite it otherwise being relatively compatible with Filecoin L1. So that's maybe a friction point and something for us to look into. If you have these friction points solved around, Protofire offering an ETHRPC API and Gold Sky providing subgraphs, then I think as a builder, you don't really, it's not that hard, right? You have to be able to configure this with your MetaMask in order to call the smart contract, so you can have the demo app and all of these amazing applications that builders have created running, interfacing with that. But you're gonna need to be able to easily take USDFC that you purchase on mainnet and put it into a Filecoin Pay wallet on IPC subnet.
We've deployed USDFC, but I have not tried to bridge the USDC in yet.
Yeah, and so you'd have to and that would be an additional bridge step, because you have to purchase it, then you have to bridge it to another network, then you have to lock it in your payment contract. So that pretty much every time that you're depositing and doing other things, there's some hurdles there about and when you bridge, you're locking that into the IPC subnet contract on L1 and doing your activity.
I'm really curious on the cost and timing too, to see if it's viable.
Yeah, I mean, luckily it's once you've got it there, you have 1 second subnet, so it's going to work really fast.
And
if you get it there, it'll take
that was
you
a day's worth of tweaking, so we could probably get it faster if we really wanted to.
I have a question. If I use my MetaMask wallet to interact with this IPC L2, it will be a different network, won't it? It will not
Yes.
look like Filecoin. And it will not look like Filecoin. I will have two wallets.
Correct. It's a
But
yeah.
two MetaMask
Network
account.
ID.
One is for Filecoin, one is for FOC, L2, IPC, whatever we call it.
I mean, it's the same way when you switch between calibration and mainnet, right? Or you're using the same wallet, but you will need
Right.
to have it. You'll have a different vault within that wallet associated with that network, and you'll be effectively transferring from kind of the mainnet, your mainnet wallet to your subnet wallet, and then being able to interact with your 1 second.
Yeah, and I
or
bet we
subset
could automate that
wallets.
process to where it's pretty easy.
Would it be possible to do something like Uniswap directly on IPC L2 so that I can buy USDFC directly into my L2 wallet instead of going through L1 and then passing it
I
around?
believe you could. Yeah.
Yeah, I mean, right now, then you would need effectively sushi swap pools into, a USDFC pool on the subnet.
Yeah. That's
so
something I intended to look into.
Yeah, a chunk of infrastructure to deploy there.
This looks suspiciously like our previous conversation about deploying to other chains versus bridging to Filecoin. Just a note.
Just like syncing the overhead, it's like every single subnet it's gonna ship with like you tried that while we were trying to do local DevNet testing. It's like deploying a USDFC and deploy all the contract we're having, and then user can have access to fucking pain in the ass. Yeah, how can we solve that bridge? It's like is that the only way that we think we can do it? It's like literally deploy each single individual component on all the subnet. Is that the only way?
That's a great question.
I don't know. I wonder Kuba, which is very smart, has a better idea of how we can do this. Because you were telling me you have.
Deploying a subset of contracts onto the network so that
Or could there be some sort of proxy contract that helps to pass the requests along? Or
yeah, but
We can maybe put in some optimistic and sponsorship options into this where it's like, we assume that this will eventually settle. And so we just take that assumption window and say it's okay. It doesn't need to be, exact, and we have some way of recovering, or like we could say it doesn't have to resolve exactly there, that we know it will eventually resolve here, and that's okay.
And that was where I went. I guess the nodes could cache the file, or that's where I was thinking about Basin. If Basin cached the file until it was for sure on the L1, but it could just be cached on the node too.
Does IPC support all the precompiles that Filecoin supports? For example, the randomness thing. If we put the contract of PDP uses this precompile, the RANDAO, whatever.
are you using the RefFEM?
I
In
believe
your IPC
so.
subnet.
I'd have to double check, but I believe so.
Yeah, I believe that IPC subnets are running RefFEM, and this is a new testnet, so it could run the latest version of RefFEM, and that is the WASM runtime. The WASM runtime and the ETH runtime in an IPC subnet are coming from RefFEM. And so it is the exact same set of precompiles, and it is also the exact same WASM container that all of the Filecoin built-in actors run in today. And you could deploy, as part of the subnet, any other WASM applications that you would want into the WASM runtime of the subnet as well.
Cool. So this is not a blocker.
I have a question about DRAM. Will the L1 smart contract see the same DRAM beacon values as the one inside the L2? And also, if the blockchain is different, then how is this going to sync?
They're subscribing, I believe. Oh, okay, same DRAM values. No, so if it's a 1 second subnet, then they would be subscribing to a faster DRAM
Okay.
network.
PDP validator logic will use different sampling method on L2 than on L1. So how will we verify that once we send the verification broom from L2 to L1, then L1 is not able to verify that the L2 used the correct randomness beacon. Little issue. Yeah, L3.
Like it should be able to validate at the L1 should be able to validate that the randomness beacon that they're using and the proofs line up, not that they are the same as what L1 would be doing, right? You can validate that against the DRAMmed network, but you just know it's a different network ID than the one that's default used in mainnet.
Is there a DRAM chain that is fast enough so that we can get unique DRAM beacon for each IPC block? I think it's 1 second.
So you're getting a new DRAM randomness epoch every 3 IPC epochs?
I think so.
How are you doing intermediate epochs?
Not
Without
sure.
randomness? I don't know.
I think that's just one of the things to explore or to be aware of.
Good call out. It's recorded, so I figured I'd go back through it later. But yeah, any other call outs on things that might block us or reasons this might not work?
I mean, I think our current takeaway is like the user friction of going from like getting in and out of the network right now, that number 3, like my current hypothesis is like number 1, assuming everything works the way I think it works, that should be really easy.
Yep.
And that shouldn't be a problem. If that doesn't work, then the whole subnet is unviable because that means you can't get Phil out of the network to a random address on L1. And if you can't do that, then fuck everything. Like, it's not worth it. Blow up the whole idea. Number 2, like, is a problem, but I don't think it's the biggest problem around like how storage providers interface with the network.
Yeah, I think
The
it's kind of
biggest thing here is
a
like
contract or we connect directly through some sort of additional RPC or.
yeah. But the same problem with storage providers is the same problem with everyone else, which is like, actually not quite. Storage providers have more of a hurdle because they're running a lot more different infrastructure, whereas almost all of your developers and users are interacting via ETHRPC APIs. So as long as you can surface all of the data, like then you're just changing the chain ID output and they interface with the new contract instead of the previous contract. But having your storage providers interface with the L2 instead of the L1, which would be required if you want to do payments and messages landing on the L2 quickly, not waiting for a block time. Like you could maybe do something in parallel effectively. I don't know. The thing I was imagining there is like the SP is effectively, okay, maybe you could have the SP submit their things to an ETHRPC API that like puts them on chain, like some sort of like message passing system.
Fallback?
No, like effectively you're effectively running a light node on the network and you're pushing signed messages as a storage provider onto some endpoint. And your storage providers aren't even actually running a node in IPC or connecting to it. They're just pushing signed messages, which is the user signed message that they handed it to them to some IPC API interface.
Could work.
And the main thing that you then, maybe there's a subset of a thing that you're pushing to the previous point, a subset of a thing on IPC, which is like it's just kind of an intermediary thing that's holding payments and rails before a lot of stuff then happens on L1. I don't know. It seems like that's a non-trivial blocker and that will, like you would have to build up a lot of infrastructure in order for us to deploy this on the network. It's good infrastructure for you to have anyway. You need ETHRPC APIs, you need subgraphs, but the bridging thing is going to be the biggest blocker. I don't have a design for it right now. And I think the friction for all of us would be now we're pushing all users and applications to use this subnet. And we would actually probably prefer to have all of that activity on Filecoin L1. So it's like not worth it.
We might be able to explore some subset of functionality that is currently too painful that we want to push onto an L2 and keep the rest on the L1. Like proofs, for example. We don't need proofs to be fast. Once every 24 hours, we don't need that to happen elsewhere.
That's true.
It's a lot of the payment stuff is frustrating, and maybe some of the onboarding stuff. Maybe there's a subset here we do on an L2 and keep the rest on the L1.
I have two questions. The first one is like stupid because I just don't know how IPC works. It's like, how does a subnet actually joins Filecoin L1 and say, I'm a Filecoin subnet now? Do they stake? Do they get block rewards? Like, what's the mechanism there?
So there's a contract on the L1 that you deposit funds to, and then it basically pinpoints the genesis for the subchain. And so it verifies that subchain is legit.
So there's a
Yes, the validator.
Gotcha. So there's a basically subnet registry on L1 right now.
Correct.
And then the validator nodes for the subnet, their fund for that subnet is coming from the Filecoin L1.
Yes.
Gotcha. Thank you. The second is like, I actually don't agree with Molly that the group 2 is like the file flow architecture is like easy to solve, because like Wednesday I have been thinking since like thinking about like subnets is like, let's say we have like a million subnets, right? Like not say a million, 10. Don't you scare people? Say 5 regional subnets that are all having the data like stored and so on and so forth. How does like retrieval works from the Filecoin L1 level? So like Filecoin, we're talking about data gravity. People come to you Filecoin L1 is they know there's a CID being stored on Filecoin, and I want to build things around this CID. For example, I'm building Filecoin Beam as the data delivery layer for Filecoin Onchain Cloud. Now, does that mean I will be able to still know all the CID that's stored on Filecoin subnet by listening to some event or state on the L1? Or I have to deploy a indexer listener to listen to all the subnets, to gather the CIDs from all the subnets to provide a data delivery layer for like Filecoin as a whole? Like, how would that work?
Yeah, it's a lot. I think I imagine that they would sync, because we don't want to have people run their own.
If it's the latter, I think it can be very expensive, right? Like, because like indexing each chain, like right now, even indexing one chain can be expensive. We're talking about like 5 potentially, if we're successful, fast growing chains, and taking all those CID information on that. Isn't that going to be hard?
Every regional chain will see only 1/5 of the traffic. If you have 5 regional chains, then each chain will see only 1/5 of the traffic. And if you are billed per transaction, then it will pay only 1/5 of the whole amount per region. So it will add up to the same price.
I hear that. I feel like data gravity is happening at a subnet level. We won't be able to build a more universal global Filecoin L1 level that has those like interoperability.
And is it a plan to have multiple regional subnets, or will it be only one global L2 for entire FOC?
Open design question. You could do it either way. It's an open design question. You could do it either way, but Jennifer was saying there might be value in doing it the other way, or the multi subnet approach, if you can make it really easy so that you don't, because as a user, you don't want to have to go and bridge separate funds to every separate IPC subnet. That would be super painful. But again, if you can deploy just a subset of things into an IPC L2 or something like that, then you could have different subnets that are scaling total regions. But, then right now, I don't believe there is any way where like subgraph information is being piped back to L1 from an IPC subnet. It's just like just a checkpoint of state of like, this is where we've gotten to. It doesn't actually include like an index of the information within that state that you could then parse and process at the L1 level.
We would need to listen for, or we would need to index subnets anyways, because we want 1 second indexing time as opposed to 30 seconds waiting for the mainnet finality. Right? So it doesn't matter if it rolls up to the L1 state or not, we still want to index L2.
So back to the multiple subnets, you could have one subnet under the L1 that then dynamically controls sub-subnets as well. That could grow and shrink as needed.
Just we're 15
we're-
minutes over, so can we wrap
We're
up, go to the
past
next
time.
session?
Yep. Any
Sarah?
final questions before we wrap it up?
When it will be ready?
Yesterday.
Some interesting
sure. Let's-
design questions to go in and
Yeah.
research.
So anybody that's interested in this, and if you're not and you know a lot, I would love to talk to you. I want to try to get you in Slack. I might hit up Jenny to help me find everybody's contacts and get you in our Slack channel, because we have a channel for this. I think it's potential here, and at least it'll help us put together requirements that we could be using for other things as well. If you know anyone in the PL ecosystem that could possibly use IPC, please let us know. We're about to start looking for people to, be alpha users. So please let us know. And yeah, thanks.